This is problem number 8 of the 2012 AP Calculus exam. A tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate of R of t, where R of t is measured in liters per hour, and t is measured in hours. Selected values of R of t are given in the table above. Using a Wright-Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals 15 hours? Let's go ahead and begin by drawing a graph. This first axis is representing our rate at which the oil is being pumped into the tank. That's R of t. The second axis is going to represent our time, t, and that's t is in hours. Next, we're going to put the information in the graph using the table, and we'll start out when time t equals 4. So let's put a mark at 4, and let's put a mark on the graph on the rate as being 6.5. And let's put a point on the graph representing that data point that's from the table. And let's look at the next one, 7 and 6.2. So let's go over to 7. Let's go up to 6.2 and put a point. Let's do the same for the next two values. We'll have 12 and 5.9. And then the last one will be 15 and 5.6. Let's go ahead and draw some vertical lines here to represent these intervals. And it says we're using a Wright-Riemann sum with 3 subintervals. So we're going to start on the right-hand side and go left. So use your point on the right and go left. We're making a rectangle. Again, start on the right and go left. On the right and go left. But remember it said there were 3 subintervals. So there's my 3 intervals. But what about this time from 0, time t equals 0, to the time t equals 4? Well, there was already oil in the tank. It says the tank had 50 liters of oil at time t equals 4. So we need to represent that as 50 liters in this first 4 hours. Next, let's look at the time frame of each of those intervals for the Riemann sum. From 4 to 7, I see 3 hours. From 7 to 12, I see 5 hours. From 12 to 15, I have another 3 hours. We then have these rates. That's the height on our graph. And so the first rate is at 5.6 liters per hour. The second rate is going to be at 5.9 liters per hour, and the third one is at 6.2 liters per hour. So when we use this Riemann sum, we're going to be looking at the rate times the hours. So that's going to end up being 6.2, that's liters per hour, times the 3 hours. And we notice the hours are going to cancel, and we're going to be left with this number of liters. So we'll have 6.2 times 3 is 18.6 liters. Then in the second time frame, we have 5.9 liters per hour for 5 hours. And again, the hours cancel, and we're left with liters. And 5.9 times 5 is 29.5. And again, that will be liters. This last part, we will have the rate, which is 5.6 times the number of hours, which is 3. The hours cancel, and I'm left with liters. 5.6, and let me write that above. 5.6 times 3, which will give us, let's see, 16.8 liters. But I don't need to forget this 50 that we had from 0 to 4. So I'm going to put that out front. We had 50 liters to start with. Now it asks for this approximation, so all we've got to do now is add the terms. So if we get 50 and 18.6, and this is a non-calculator section, so you'll have to add it by hand, and 29.5 and a 16.8. Alright, so I have 11 and 8 is 19. We'll carry the 1. We'll have the 9 and the 1 making 10, 8 and 6 is 14, so that's 24, and we'll carry a 2. And then we're going to end up having 2 plus 5 is 7, plus 1 is 8, plus 2 is 10, plus 1 is 11. So 114.9 liters is going to be our answer. 114.9. And that's the number of liters of oil that are in the tank at 15 hours. I hope that helps. The answer is letter C.